In the year 1929, Robert van de Graaff designed a machine which produced a large amount of electrostatic potential difference up to several million voltage, nearly 10 to the power 7 volt. This Van de Graaff generator works on the principle of electromagnetic induction. This is a very important. Van de Graaff generator works on the principle of electromagnetic induction. A large hollow spherical conductor is fixed on the insulating stand. So here a pulley B mounted at the center of the hollow sphere and another pulley C is fixed bottom of the Van de Graaff generator. A belt made up of a rubber. So this is a belt made up of a rubber over both pulleys. The pulley C is driven continuously. So here the pulley C is driven continuously by the electric motor. Two comb-shaped metallic conductor E and D. Two comb-shaped metallic conductor are fixed near the pulleys. E and D are two comb-shaped metallic conductor fixed near the pulleys B and C. The comb D is maintained. So here we maintain the comb D is maintain a positive potential nearly 10 to the power 4 volt by a power supply. The upper comb is connected to the inner side of the hollow metal sphere. Due to high electric field near comb D, so we are connected with the 10 to the power 4 volt. Due to that high electric field near the comb D, air between the belt and comb D gets ionized. The positive charges are pushed towards the belt and negative charges are attracted towards the comb D. So here the air between the comb and belt which is get ionized due to the high potential difference. The positive charges push towards the belt and negative charges push toward the comb. The positive charges stick into the rubber belt and it goes to the comb E. So when the positive charges goes to the comb E, a large amount of negative positive charges induced either side of the comb E due to the electrostatic induction. As a result, the positive charges are pushed away from the comb E and they reach the outer surface of the sphere. Since the sphere is a conductor, the positive charges are distributed uniformly on the outer sides of the sphere. At the same time, the negative charges nullify the positive charges in the belt due to corona discharge before it passes over the pulley. When the belt descends, it has almost no net charge at the bottom. At it gain again a large positive charges, the belt goes up and delivers the positive charges to the sphere, outer surface of the sphere. This process continues until outer surface produces the potential difference order 10 to the power 7, which is the limiting value. We cannot store charges beyond this limit since the extra charges starts leakaging surrounding spaces ionization in the air. The leakage can be reduced by the enclosing the machine is gas filled steel chamber at very high pressure. The high voltage produced in this Van de Graaff generator is used to accelerate positive ions for nearer its nuclear disintegration and other applications.
In this module, you will learn the principle and working of a Van de Graaff generator.
What you saw was no magic. It happened because this machine, known as the Van de Graaff generator, produces a charge which travels on to the person who touches it. The charge acquired by each hair is same, so they repel each other. Due to this repulsion, they all stand on their ends.
Robert J. Van de Graaff in 1929 designed the Van de Graaff generator to generate electrostatic charges up to 10 to the power of 7 volts for experiments in nuclear physics. A Van de Graaff generator has a belt of an insulating material that carries charge, a lower pulley and an upper pulley on which the belt moves, an electric motor to rotate pulleys, a spray comb near lower pulley to spray charge on the belt, and a collector comb near upper pulley that collects the charge from the belt, and a hollow metallic sphere on which the charge is transferred from the collector comb. In this process, the collector comb keeps collecting the charge, and as the net charge inside the hollow metallic sphere is zero, it transfers the positive charge to the outer surface. As the charge on the hollow metallic sphere keeps on accumulating, its potential increases too. The charge then leaks into the medium after the limiting value of potential. This leakage can be minimized if the generator assembly is housed inside a sealed chamber filled with nitrogen or methane gas at high pressure. Van de Graaff generator is used as a particle accelerator in nuclear research. It can also be used in food and process sterilization, pasteurization, and as an alternate source of electric power. The main parts of a Van de Graaff generator are a belt made up of an insulating material, two pulleys, a lower pulley and an upper pulley, an electric motor, two metallic combs, spray comb and a collector comb, and a hollow metallic sphere. The belt carries the charge from the lower end to the upper end and moves over two pulleys, a lower pulley and an upper pulley. An electric motor is used to rotate the pulleys. Spray comb is held near the lower pulley. It sprays positive charge on the belt. Collector comb is held near the upper pulley. It collects the charge from the belt and transfers it to the hollow metallic sphere. The hollow metallic sphere is a large hollow conducting sphere which is supported at a suitable height over an insulating pillar. It receives the charge from the collector comb.